This
Yeah. So,
conference will now be recorded.
so then after that, after understanding all those things, we'll go into Ethereum. Ethereum is basically a type of blockchain. It's an application of a blockchain wherein we generally write code. And basically, if you see most of the, we can create private blockchains as well as create public blockchains. So this is basically a public blockchain, but we can use the same software to create our own public blockchain, whether it might be supply chain or anywhere. So but then within those three, there are many things we need to understand. Like it has its own virtual machine called as EVM, and then there is a certain pricing which is involved within it, and then there are different consensus models as Venkat had highlighted, proof of work, proof of stake. Venkat, I think, yeah, Venkat had highlighted about it, and then we'll get into the nodes. What is a node basically? What is called a node? Um, and then we'll get into the smart contract for programming wherein we need to understand. So basically in smart contract programming we have a programming language called as Solidity. So Solidity we have we will go from the basics as such, from the data type level, what are the different data types and how to declare it, how to initialize them, then run the functions, and then along with that events. We have certain things in that, and it is a bit different than the legacy programming languages, but also same. It's a bit different but also same. And then you can then we'll be implementing one decentralized application, then we'll create a private blockchain, and then we'll also put in contracts over there and see how it will work. So this is the course. Um, so so I'm just moving on. I'm just moving on to today's topics. That is, first, let us understand what blockchain is. Okay. So some people have already spoken about blockchain. If anyone else can, whatever they have understood, if they will tell to me, if you can put across to us, it will be great. So anyone who has joined newly, they can speak about blockchain, whatever you have understood. Yeah, Rajshekhar or like Pramod, anyone. You can speak whatever you have understood about it. Srini, yeah, Srini, you can also speak about it.
No, I'm good. Like I mentioned, I'm just trying to learn here.
Fine, fine. Chalo. So we'll just dive into this. So basically, there are certain terminologies that we need to keep in mind when you're reading about. There is a bit of disturbance. Srini, can you mute yourself?
Sure.
Yeah. So there are certain terminologies which we need to keep in mind. So when you were reading about blockchain, maybe you have come across certain terminologies called as peer-to-peer, decentralized, consensus. So they say that how blockchain is different from the legacy systems. These three are the main important points which actually come through. So we're just speaking about blockchain. So blockchain was basically invented in 1991 by a group of researchers, but then the technology was still not there to implement it. But then in 2009, there was a white paper that was just after the financial crisis that had happened in US. In the 2009, there was a, you can say it is an anonymous person or it can be an anonymous entity. His or that entity's name was Satoshi Nakamoto. They published a white paper, and the publication, it was about a peer-to-peer currency wherein you do not have a third party involved. So right now, let's say that if I want to transact to Srini or if I want to transact to Surya, if any one of them, if I want to send money in between, there are banks involved. But then this concept was different. This concept was designed on top of blockchain in such a way that we can do the transfer of the value. That is, I can transfer any currency to you. That is, they have their own currency called as Bitcoin. So when I transfer those Bitcoins to you, there is no third party involved as such. So that was the whole concept. So the first white paper was Bitcoin. So Bitcoin is an application. So Bitcoin was the first implementation of blockchain. So blockchain is a technology, and Bitcoin is a, what you can say, it was the first application which had come up. So people started, installing that software and started becoming nodes about which we'll be learning. And then after 10 years down the lane, people are thinking that people are using the same technology for multiple things, to reduce the friction in many places which was there. So we know that internet actually made the world smaller. Right now, see, you are sitting in US and I am in India, and we are still able to communicate to each other. Business deals are done, you know, sitting at different countries, which was not possible, 30 years back, or 40 years back, these all things were not possible. But now see how internet has made the world smaller. If anything happens in India, or if anything happens in anywhere in the world, you will be, updated about it. It is so easy. So that's the reason why I say the world has become smaller. But then there is still an issue with the currency. That is, like, for example, if I want to transfer a value, if I come to US and if I give you rupees, it will not make sense, right? You won't be accepting it. Again, I need to convert that into the dollar, and then dollars I need to pay. So internet could actually made an internet of information, but then we never had an internet of money. That is, like, if I use the same money, I can go anywhere on the internet and buy anything, or like I can go to any country and spend it. So that kind of system was not there. So this is one of the problems that Bitcoin has actually removed. But then there are many other things which will come in. So just to understand it, we'll be understanding blockchain in three different ways. Okay. So let's say that three people are sitting in a room. Let's say that myself, Srini, and Surya, we three people are sitting in a room, and let's say that the total amount. Are you all able to see my screen, right? Yeah. So let's say that there are $100. Okay, $100 in the room. Let's say that there is only $100 in the room, and let's say that myself, Srini, and Surya are sitting in the same room. Okay, so and then let's say that in that room only $100 is there, and I have $40, Srini has $40, and Surya has $20. Okay, and we all three, just we will actually keep maintaining the balances of everyone in our. Let's say that we all have three sheets of paper. Okay, let's say that I have a sheet of paper, Srini has a sheet of paper, and Surya also has a sheet of paper. And then we are actually maintaining the balances in our piece of paper. So this is just a level one understanding of blockchain. Then we'll go to the next step. So this was Harsha, right? And then next comes Srini. And the next comes Surya. So what did I say? The balances, the initial balances were the initial balance was Harsha was $40, correct? Srini was 40, right? Surya was 20. So what did I do? As soon as I know that the present state, this is the present state of $100 in that room. So what I did was, to be safe, because we don't trust anyone with money, right? We don't trust our family members either. So yeah, so that is the reason why. Let's say that I have noted down the balances in my piece of paper. So in the same way, what will Srini do? Srini will also note down the same thing in his piece of paper. In the same way, Surya will also do the same thing. Correct. So now let's say that this is the present state. This is the first state of $100. Okay. Now let's say that I wanted water bottle, and then I'll say, Surya, hey Surya, can you give me the water bottle? I'll pay you $10. Okay. I think $10 is a huge amount, but but for this moment, let's understand that I'm giving $10 to Surya for something. So I'll say, Surya, hey, can you give it to me? Then when I'm actually giving those $10 to Surya, I shout out loud in the room. I shout out so loud in the room saying that, hey, I'm giving $10. So when I'm doing that, Srini listens to the transaction, right? Srini is there in the room and he listens to the transaction. So when Srini listens to the transaction, what Srini does is he updates the balances. He makes Harsha's balance as $30. Srini's balance still remains the same. Okay. And then Surya's balance increases by $10, which becomes 30. So in the same way, Surya will also update his balance, right? And then in the same way, Harsha will also update his balance. So here you can understand one thing is that this is a peer-to-peer system. Okay, this is a peer-to-peer system, and in this peer-to-peer system, we are able to do a transaction. We are doing a transaction by having consensus. So this is what I was speaking about. This is a peer-to-peer consensus mechanism. So here there is no third party involved. We don't have a bank in between which is actually changing its databases. So that is the reason why this technology is great. This is a peer-to-peer consensus technology wherein we can transfer value, with trust. Okay. So this is just a level one understanding. If any one of you have doubts, you can please ask me right now. I have 2 minutes. Hello. Any one of you, it's fine. Yeah, Srini, Teja, any one of you.
So at the beginning, is it like a mutual agreement that you have this much of virtual currency and I have this much of virtual currency and so on and so forth? I mean, anybody can just declare I have so much money, right? That doesn't mean anything. What is
No,
the rationale or basis for them to declare you have only 30, I have 40, or Surya has 40, and you have 30, and I have
this
30?
is just for understanding. But then the total
Okay.
amount in that room is $100, right? So that is the main difference. It can't be more than that. So the total amount is $100, and let's say the present state is 40, 40, 20. You know,
Okay.
but then we'll understand about how everyone gets the initial state later. Okay,
Okay.
but for
All right.
just to
I'll wait for
understand,
that.
yeah, yeah. So this is basically, I just wanted to. So the main thing what you need to understand is that it's a peer-to-peer consensus mechanism where I was able to do a transaction. So that is the main thing which I want to tell. Yeah. Any other questions, or I'll move forward? Chalo. And I'm going to the next thing. Yeah. Now, so basically, can you understand that it's a peer-to-peer model and all these things. But why is it called a blockchain? Why is it called a blockchain? Can anyone tell me why is it called blockchain? Any one of you?
It probably got continuity from one to the other,
Okay.
with no real documented transactional information.
Um,
I don't know,
uh,
maybe there's some documentary.
yeah, it's actually documented. Chalo. That's
Okay.
the reason why it's called blockchain. Yeah, any one of you, please. Yeah, carry on.
Yeah, my understanding is, Surya here. It's like, all the transactions that are shouted in that room are recorded in a block, and where the blocks will be published once the block is full.
Correct, correct. It's close to that.
And,
You're almost.
I mean to say, each block is linked to the other block, so that whatever transactions happened in the previously will be linked to the next time into the next block. And next
Correct.
block, every block will be hashed or something like that.
Correct, correct, correct. So you're almost close, Surya. So basically, why is it called a blockchain? Is because it is actually blocks of data cryptographically linked to each other. Okay. So this is a block of data. Block of data, I mean, is data space in our computer and the mobile, MBs, GBs. That thing I'm saying. So it is a block of data cryptographically linked to each other. That is the reason why this is called as a blockchain. See, you have blocks and they are chained. You know, they are chained, so that is the reason why this is called as blockchain. Okay, but then there is one question from Teja, I guess. So I just want to see that question. Just a minute. There is one question by Teja. Yeah, is the $100 a bank or an organization? I could not able to talk. I am unmuted also. Okay, Teja, it's better you rejoin once more. But then first listen to this. This is not an organization. The $100 is basically, let's say there is only $100 in a room. It's no bank or organization or anything. Let's say that there was $100 and the $100 is used within that room. That's it. Within that ecosystem, those $100 are being used. Just keep it till there. But then the main point what you need to understand is that I was able to transfer the money without a third party. So there is no bank involved over there. So that is what I wanted to speak about. So if you have these unmuting, muting issues or audible issues, it's better you rejoin quickly. Okay, chalo. I'll be moving on to the next topic. The next topic, within this topic only, the next point which I want to speak about is basically about blocks, a single blocks. Let's understand a single block. Okay, here what I told is that there are blocks of data that are cryptographically linked to each other. But before that, we need to understand what a single block does. So here we will be speaking about a single block with respect to the Bitcoin blockchain. Okay, as Bitcoin is the first implementation, let's understand blockchain through its size, because every other thing which has been made is basically a form of Bitcoin only. Okay, a bit of differences they have done, but everything has originated from Bitcoin. So let's take a single block. Okay, okay, and now as we had let's say that we had papers with us, right? Me, Srini, and Surya had papers with us. So in the same way, let's say that we had data space. Let's say that we have what do we say, we have databases with us. So let's move on from there. Let's move on from the papers to let's come to the technical part. So technically we'll be having databases with us. Okay, so now, so let's say that this is a block of data. Okay, now there are certain parameters associated with a block of data. Okay, every block of data will have certain parameters in the blockchain. Okay, but in Bitcoin, there are two parameters. The two parameters of a block are block size. Okay, and the another one is block time. Okay, so let's take this. Let's take the first one. Okay, so every block in a blockchain, every block of a Bitcoin is of size 1 MB. The maximum size of each block is 1 MB. That is, the amount of data that can be inserted into each block is 1 MB. Okay, then the next comes block time. Block time is nothing but the time taken for the next block to be created. So let's say that there is one block. The next block, so I told this is block, this is block, this is block. So after this, when will the next block be created? The next block will always be created after 10 minutes. Okay. So there are two conditions. One is block size, another one is block time. Okay. These are two parameters. Now, what happens is that whatever transactions I am doing, so what was the first transaction? First transaction was between Harsha to Srini. Right? Harsha to Surya, I guess. Yeah, Harsha to Surya. It was how much? It was $10. Correct. So what happens is that as I was writing down in my paper, in the same way, the same transaction can also be written in my database, right? So let's say that this transaction is getting written into my database. That is a single block. Let's say it is getting written into a block of data, and that block of data is of size 1 MB, and the next block will be formed after 10 minutes. Okay, so Harsha to Surya transaction is added. Now let's say again Surya does a transaction to Srini. Okay, and he gives $5 to him. Okay, and then it goes from Srini does it to Harsha. He gives again $6. Let's say he sends $6 to Harsha. Now, like this, these transactions are getting added to the block. Now, can anyone tell me till what size can I add these transactions? Till what size can I add the transactions in the same? See, whenever I'm adding a transaction, it is eating a data space. It is getting the string is being saved.
1
So
MB.
till what size? How
Is
much?
that 1 MB? 1 MB?
One. Correct. So till 1 MB, I can be till the 1 MB space is not filled up. I can keep on adding the transactions. Or let's say the 10 minutes is over. Okay, let's say the 10 minutes is over, but no transactions were done. What will you do at that time?
You do nothing, I guess. You still keep that block open. Otherwise, you will end up having multiple empty blocks, and there's no real transaction for you to link one from one block to the other.
Yeah, no. My question is that let's say the 10 minutes is over, but the block is not filled. What will we do? For example, in the 11th minute, a transaction is done by me to Surya. 11th minute, I do a transaction. Where will the transaction be added? That was my
So
question.
you got another block or what?
Yeah, we create a new block, and the remaining space will be taken as a null string, like vacant string spaces. Okay, you cannot put a transaction into that once 10 minutes is over. So a block can be changed, or you can play around with a block within 10 minutes. After 10 minutes, that block becomes immutable.
So
Okay.
Okay.
Harsha, question.
Yeah, please.
What happens if the 1 MB block filled in 2 minutes?
Yeah, so that's the next one. Very good, Venkat. So if it gets filled in 2 minutes, what happens is that the remaining transactions will be sitting in a queue, and the next transactions can only be added in the next block. That is, after 10 minutes, the 11th minute only the transaction can be added. Okay. So, but then mind it, this is for Bitcoin blockchain. We can always, configure our own blockchains, and in our private blockchains we can change it. So you don't think that this is the only one standard we need to follow. But as I told that I'm going through Bitcoin. So if transactions of 1 MB is filled within 2 minutes, you have to wait for 10 minutes, and in the 11th minute only the next transaction will be added. Am I
Okay.
clear about?
Uh,
Yeah, please question. Yeah.
Yeah, I just got one other question. Let's say you do not have any transactions that are more than 1 MB, and you pass 10 minutes,
Okay.
and there's no real trigger for you to create another block of 1 MB for 10 more minutes. But would the system goes on just creating
Yeah. It will
the
keep on
blocks?
creating. Yes.
Okay.
It will keep on creating blocks. Yeah. It will not be stopped. So yeah, so this thing is very clear for you people. If you have any questions, you can ask in the chat. If you are not able to speak, you can ask in the chat, or you can directly ask me. I'm moving on to the next one. So these are the two parameters that are associated to a block. But then there are certain more parameters which are important. Okay, which are important, which basically is basically used in linking one block to the other. Okay, so there are certain things. One thing is that uh, so for every block, there is a reference of the cryptographic output of the previous block. Let's call it previous hash. Okay, let's call it previous hash, and then every block has its own data set. Correct? Every block has its own data set. That is, let's say all these transactions, these whole transactions in these blocks, let's call them data. That is a data set. Let's call them. Can the queue hold more than one MB? Yes, yes, yes. Yeah, it can hold how many. It depends on how much space you allocate. That is also called as a memory pool. So basically, Teja is asking that can the queue, that is your thing. When you told that, within 2 minutes, if the transactions are filled, what will happen to the other transactions? That was a question which was asked just now. So in line to that, Teja has also asked a question. The question is that can the queue hold more than 1 MB of transactions? See, queue has nothing to do with the blockchain. Queue will be just maintaining a queue of all the transactions that are coming in, and it will add transaction one by one to the next block. Okay, so queue is also called as mempool. That is called as mempool technically in Bitcoin. What do we say in mining? Okay, we can say that if you're a node, you call it a mempool. Okay, you can also call it a queue, whatever it is. So basically, any transactions which are coming in will be in queue, and it depends upon how much data space you have. You can have how many number of transactions that you want sitting in the queue. But in the block, only 1 MB of transactions can be added within 10 minutes. Yeah, so coming back here, what I was saying was for every block, we have three different parameters. So three different parameters are the previous hash, that is a cryptographic reference of the previous block, okay, and the data set, that is the whole data of the present block, and then there is a small random number called as nouns, okay, it's called as nouns, about which we'll be discussing in the in the next page. Um, okay, this is called as nouns. Yeah, so there are three parameters for every block. One is the previous hash, that is a reference of the previous block, the whole data set of the block, and there is a random number called a string, okay, about which we'll understand next. So, and then, so these are the three things. And then, in the first page, in the previous page, here we were maintaining pages, right? So let's call ourselves registrars. So registrars are nothing but registrars basically have the data, right? They have a track of data. So registrar is nothing but he has a track of data. So let's say that myself, Harsha, Srini, and Surya were registrars. So that is in the physical world. But in the software terms, we call ourselves as nodes. Okay. So we three were actually nodes. Nodes is the term that we use for registrars in blockchain. So we are nodes. So also remember that every node will be having number one, data space. Okay, data space is nothing but database. Okay, and the second thing what they'll be having is computing power. Okay, computing power, that too huge amounts of computing power, about which we'll understand in the next page. Huge amount of computing power. Yeah, so these are the two things every node has. Here nodes are nothing but Harsha, Srini, and Surya. We three were nodes actually. We have huge amount of data space, and every block size is of size 1 MB and 10 minutes. So if you have any questions, please ask me, or else I'll go to the next topic. I have 1 minute. Anyone?
So you said earlier these are all private, private, ecosystem, right? That's why they are interconnected. Probably I have a question more around public network. If you have three different companies, how are they get connected to each other as
Yeah, that
blocks?
we'll do it slowly, Srini. That's like
Okay, fair enough. That's fine. I can wait.
no, here what I'm speaking about is this is not about public or private or anything. We are not, I didn't speak about that anywhere. I'm just speaking about a block. That's it, a block of data in a blockchain. Whether it might
Gotcha.
be public, whether it might be private, it will work the same. So do you have any questions related to a block which I just spoke about?
No, I'm good.
Yeah, anyone else? I keep Teja is asking. Can you, okay, repeat the note? Yeah, so Teja, if you had seen the previous page, that's what I was saying. I was making a reference from this page to the node. Here, are we three people, Harsha, Srini, and Surya, we three people are actually maintaining the balances of each other, such that I can trust the system. So what I did was I was maintaining it in my sheet of paper. Srini was also maintaining. Surya was also maintaining. But here, this is in a physical world. We will call them also as registrars. Okay. So here, basically, but in software terms, we won't have a sheet of paper, right? We'll be having database where we'll be writing all this data. So what the transition what I made is that there we had a sheet of paper. In the software terms, we'll be having databases with us, and we'll also be called as nodes. Okay, and every node, so the registrars are nothing but nodes in blockchain, and every node will be having a data space such that they can hold the data of all the transactions that are happening, number one. And the number two is they'll also have computing power. Computing power is nothing but the CPU. Let's say in our laptop we have a CPU, it's a processor, it has some computational power, correct? But in blockchain space, you need to have huge amount of computing power if you want to become a node. Okay, if you just want to use a network, you need not have to have huge amount of computing power. But then if you want to become a node, you need to have a huge amount of computing power. I think I'm clear. I think I made this thing clear. Uh, who will allocate data space and how you determine? So that is basically no one allocates anything to anyone. You have to. So in a public blockchain, as the transactions are happening, you need to keep adding your data space as you're keeping track of all the transactions happening in the world. Okay, and how you determine is basically when you install the software and when you're trying to become a node, you need to have a data space. First, you need to synchronize with the blockchain. See, Bitcoin had started in 2009. Lot of transactions might have happened. So let's say you want to become a member of the Bitcoin blockchain. Anyone can become because it is decentralized, right? Anyone can become. You just install a software, you can become. But then first you need to download all the blockchain data, whatever has happened since 2009 till date. Okay, once you synchronize, then all the coming transactions also you can keep noting down. So there is no one, determining how much data space you want. Network determines. That is, every 10 minutes a new block will obviously be added. So in the same way, there is no one determining how much data space you need to allocate. Yeah. So any questions more, or shall I move on? I'll move on to the next topic. So this is the final. This is the final. So till now we understood, how basically it is peer to peer and all these things. And then in the next thing, what we understood a single block. We understood what things are there in a single block. Okay. Now we'll understand. Let's understand in different one. Yeah. Let me add one more page. We'll come here. Let's make this just a minute.
Hi. Hello.
Yeah. Yeah. Tell me. Hello.
Oh, this is Shrikant here. Quick question while
Yeah.
you're drawing there. Uh,
Uh-huh.
can the node ever go offline? And second thing is, what is the incentive for anyone to become that node?
That's what we'll
Can
be
they,
telling.
what is the other term?
Yeah, I'll come into that. I'm actually coming to
Oh,
that.
okay.
Okay.
All
Yeah,
right.
and then if you go offline, we have other nodes are there. So once again, you come online, you need to synchronize with it. In public
Okay.
blockchains, in private blockchains, you should have a backup. If it goes down, you need to have a backup too. You cannot have a single node. You should have two, three nodes, such that it never goes down. In a private blockchain, private setup, I'm saying. But in a public blockchain, anyhow, there are many people in the world, so even if you go down, also it doesn't matter.
Right. And the other question was on the incentive part. Okay. Maybe you can explain later.
Yeah, I'm continuing. Yeah, sure. So see, now you can, this is a small graph which I made. Okay, in this graph there is 10, 20, 30, and the x-axis is time in minutes. So can anyone tell me that how many blocks will be created here? How many blocks will be created? How many blocks will be created?
3, I guess.
3 blocks, correct, correct. Actually 3 blocks will be created. Absolutely right. So let me create one block. Yeah, now the same. Okay, this was the first block, and as we were doing it in the first page, right, in the same way, let me start this thing with the first transaction that I did. That was from, that was by Harsha to Surya, I guess. Yeah, Surya, that was 10, correct? So in the same way, now we are creating blocks. Now we are speaking about, you're right, Teja, it is 3 blocks, correct? So now, Harsha to Surya, the first transaction was $10, right? So in the same way as I was noting down, let's start writing to our blocks, that is the data space. Now then Surya to Srini was 5, and then Srini to Harsha, let's say, let's $9 or something like that. Now what is happening is the transactions are happening. Let's say that 10 minutes is over. Let's say that 10 minutes is over. Many transactions happen. Okay, transactions are happening. Let's say that the block was filled, or let's say that the 10 minutes is over. Now, what we need to do is we will get 3 parameters. The 3 parameters that we will get are, see, here what did I say? It has a previous hash. It has a previous hash, I was saying. But here, in any blockchain, the first block is actually called as a genesis block. Okay. And in any blockchain, remember that in any blockchain, the first block is always called as a genesis block. Okay. So here, what did I say? The first parameter to a block would be the reference, the cryptographic reference of the previous block. But here, as we are not having any previous block, let's make it 0, because this is the first block. We don't have a reference of the previous block. So the first parameter of this block, there are 3 important parameters. The first parameter of the block is 0, that is the previous hash, because there is no previous block. And let's say that all the transactions that are included here are D1. Let's say it's a data set D1. Let's call them D1. Quick questions. This is Rajshekar. This question. Well, just a minute. There's a question from Rajshekar Chitala. I don't know. This is Rajshekar. This session recorded and shared at the end of the day session. Yeah. Correct. Everything will be recorded and will be shared to everyone. Am I right? 1 minute. Let me check it with Vijaya. We will be sharing this, right?
That's what we got to know in the emails and earlier communication internally here. You guys would be sharing the recording.
Yeah, good. Yeah, we'll be sharing the recording. Yeah, great.
Right.
So what I was speaking about is I was speaking about this block, right? So single block, we have a, what do I say, that the first parameter is the previous hash. As there is no previous block, the previous hash is 0. Then let's consider this whole data as data set. Okay. Now we need to understand a small cryptographic function. That cryptographic function is SHA-256. Okay. So you might have heard of it, or even if you didn't hear of it. So this is basically one-way cryptographic function. So what this function does is that whatever data you give. So let's say that I give Harsha. Every time it gives the same output. But if I change, let's say my H was capital and the remaining letters were small, it gives an output. If there is change in letter, also the output changes. So, and then the other thing is that if I give the output to someone, they will not be able to know what the input is. So this is called as a one-way cryptographic function. It does one-way hashing. Okay, it gives a 256-bit string output. So, so what do you mean by 256? Oh my God, PIT. 256-bit. Okay, yeah. So 256-bit string output. So bits are nothing but 1010. So whatever input you give it to the function, the output will be a 256-bit 101010 kind of stuff. Okay. So it's binary 1010 things. So the output will be like that. So what we do right now is, so what happens is here we use this function. We use this function to generate the cryptographic output of every block. and it takes three parameters. The three parameters are the previous hash, comma, data set, that is the data set of the block, or you can say block data, comma, nonce. Okay, nonce is nothing but a random string about which I will explain. So there are three parameters which are important, and then it gives a 256-bit output. Yeah, so this is the thing. Okay, this is a one way. So basically, this was downloaded by NSA in 1996 and 1990, between 1996 and 1998, and then this has been heavily tested. And then we use only those cryptographic functions which are in public domain and which is not proprietary. Remember this thing that whenever we are using a cryptographic function, it should be a public function. It shouldn't be a software. It shouldn't be a proprietary kind of function because it should be heavily tested. So SHA-256 is one of those and is very popular. So these are the three parameters it takes. And then let's come to the block one. Let's take our block 0, that is the first block. So what will be the inputs for this? SHA-256. And then the first input is 0, that is the previous hash is 0. The block data is D1. Okay. Now let's leave the third parameter. Let's understand what the third parameter is. Okay. Now what happens is once 10 minutes is over, the blockchain, the Bitcoin software is designed in such a way that it gives a puzzle. It generally gives a puzzle to all the nodes. So I am a node, Srini was a node, Surya is a node. So what it does is, so if I'm becoming a node, when I'm giving that amount of data space and when I'm taking care of all the transactions that are happening in the world, I won't do it for free. Why will I do it for free? So there should be an incentive attached to it, right? Because I'm using my data space and I'm noting down all the transactions. So to make this, so for any system to be, existent, there should be an incentive model, or else that system doesn't work, right? So anywhere there is no economic gain, that business or that ecosystem doesn't, if there is no flow of money, that ecosystem does not exist. So it does not, it will exist, but then it can't sustain. So for the Bitcoin network to sustain, there is a small thing that the Satoshi Nakamoto, the entity or the individual, what he had done was whenever 10 minutes is over, the blockchain, the Bitcoin network will give a puzzle. So what it will say is that put a number, put a number, this third parameter in such a way that let's say you get 5 zeros in the beginning. So the total output would be a 256-bit. Okay, the total output will be 256-bit. But what it will say is, put a number, put a third parameter in such a way that you get 5 zeros in the beginning. So now what happens is that, remember I had spoken about computing power. I told that every node has huge amount of computing power. Okay. Now what happens is me, Surya and Srini, what we'll do is we'll start guessing numbers. First I'll put 1, I will not get. I'll put 2, I'll not get. 3, I'll not get. Let's say that at 8790 I get. Okay, let's say that I am the first one. I put 8790 and got 5 zeros. So what happens is, this is called as nonce. This is a random number. Okay, this number I have found. So as soon as I found, what happens is the Bitcoin network incentivizes me with 12.5 Bitcoins. So I think someone was asking me, Teja was asking me, I think someone else was asking me about the incentive model. The incentive is this: whoever finds the nonce first will be incentivized. Okay, am I clear about it? Since nonce is nothing but a puzzle. There is a puzzle thrown to you, and you start guessing, and then whoever guesses it first gets the amount, gets the 12.5 bitcoins reward. 12.5 bitcoins is almost every bitcoin is right now, the price is I think $4,000 today. So imagine how much he is earning if he gets 12.5 bitcoins. So this is the incentive model. So any questions here? Any one of you? Any questions here? So and then let's call this nonce as N1. Any question here? Okay, if you have any questions, please ask. So this is just a number that we guess to get 5 zeros. So the Bitcoin network, once 10 minutes was over, it itself gives a puzzle to all the nodes saying that, hey, find the third parameter in such a way that you get 5 zeros in the beginning. Please, you can ask me questions right now. I think it would be a bit confusing for you, but please ask me right now. Let us make these things clear.
So it's the node that will try to make 5 zeros. Is that right?
A node will,
Is that the node that will try for 5 zeros?
no, the node, every node, like you, you
Right,
can
right.
also become, yeah. So
It
you
will
will
be
find
at
a
the node
number,
level.
node, correct. Node will try to bring 5 zeros by putting a random number. So 8790 is a number. It can be some other number also. It can be 9999. Who
Hmm.
knows? Anything it could be. It's just a puzzle thrown to you. Whoever finds it first will be getting it. So whoever will be having high computing power will be having more chances to get this. Because the amount of guesses that you make per second increases if you have more computing power.
So is there a limit on the length of this third parameter?
No, there is no limit. There is no limit. It can vary depending upon the amount of competition. So if the competition is more, the Bitcoin algorithm adjusts the complexity of it. It becomes more complex to find the number. Okay, so it
Right.
depends on the competition. If more and more nodes are competing, the complexity increases more.
Gotcha.
Yeah, yeah. So as soon as I find this number, what happens is there is a cryptographic output which comes out, and it is called as H1. Let's call it H1. H1 is nothing but hash one. H1. Yes. So this is the output. Now I want you people to tell me what will happen in the second block. Okay. First block I have told. Now you need to tell me that what will happen in the second block. That is, let's say 10 minutes is over. Now Srini is doing a transaction. Now Srini is doing a transaction to Surya or to Venkat. Okay. Or Teja is doing some transaction to Srikant. Okay. So I want you people to tell me what will happen in the second block. What should I do? What will be the first transaction?
You
Hello,
first
hello.
refresh the base balances. You readjust to how much money each of these individuals got after previous transaction.
Okay, that's fine. That's fine. That is now. Let's speak about in a transaction level. Let's not touch balances right now. Let's speak about balances. Let's speak about transactions. So first transaction, but was between Srini to Venkat or Srini to Surya. Let's say what the first transaction was Srini to Surya. What will be added here? Can anyone tell me? How will it be added? So I added transactions in the block one, right? In the same way, how will we add the transactions in the block two? So it will be Srini to Surya. Let's say $6 CSM. In the same way, I think Srini is better if you mute, it's, yeah, Surya.
Previous to that, probably we may need to enter the previous hash on this new block before we
Correct,
record the transactions, so
correct,
that
correct.
the link will be established between this block and the previous block.
Very good, very good. So what we do is that again we have three parameters here, right? So what will be the first parameter? Tell me, what will be the first parameter?
It's the previous hash which was
Yeah.
determined as H1.
What is it? H1. Very good. H1. What will be the second parameter?
It's the block data, which is
P2.
we can name it as T2, and the nouns that will be
Again,
determined.
yeah, again it will mine. Yeah, this is called as very good, Surya. So in technical terms, Surya, you can mute. You can mute. Yeah. So in technical terms, finding the nouns is nothing but called as mining. Okay. Generally, it is called as mining because you are mining for a random number. Like we mine for gold. Once you mine, you find gold, you become rich. So in the same way, this is called mining because you mine for the nouns, and once you find the nouns, you become rich. So that's the reason why maybe they have called it. They call it mining. So mining is nothing but you're finding a random number, which seals this block and gives an output. Okay. So here again we have N2, right? So this is an input here. So H1, this output will become an input here. Yeah, let's make this an input here. Yeah. So H1 will be an input here. Now what will be the output? The output will be H2, right? So output will H2. So now again, once the nonce is found, H2. Yes. Very good. So this now output is H2. Now you understand, now what is happening is that different blocks are linked to each other. See, this is the one block of data, and this is one block of data, and again one block of data. So again, let's say here one more block. Let's say now the third block is formed, correct? Now one more block will be formed. So this will be the third block. Correct? This is the third block. And then the third block, again, it will have its own 3 parameters. The transactions which are happening will be added to this block. Again, the output over here will be again H3. The output here will be H3. So in this way, what is happening is that there are blocks of data which are linked to each other. That is the reason why this is called as blockchain. And here we have a consensus, the nodes are maintained. So let's say what happens here is, what is the advantage of hashing is because let's say that if someone is trying to change the data, let's say that here I'm trying to change the data, I'm trying to change the data to 8. So what did I say? If I change the data to 8, what happens is this D1 changes, okay? This D1 changes. Once this D1 changes, the H1 will also change. That is the speciality of SHA-256 function. If any small data is changed, the output totally changes. It cannot be the same. For 2 different inputs, the output cannot be the same in SHA-256. That is why it is called as, so that is why SHA-256 is being used. So that's why I'm saying. So let's say that if I want to be the malicious guy and I want to change a transaction. Let's say Harsha is trying to change a transaction. My H1 itself will change altogether. Okay. Once my H1 will change, again the H2 will change. In the same way, H3 will change. So my whole linking of the data will only change. So the link will only break. Okay. And then how is basically the conflicts resolved? How are the conflict resolved in the blockchain network is, let's say that I'm saying that the transaction between Srini to Harsha was $2, okay, but actually the transaction had happened for $9, okay. Now how is it resolved is, if let's say I'm saying only $2, I'm being the malicious guy and I'm saying that no, and I got only $2 from Srini, but Srini told Srini has actually transacted $9, let's say 9 bitcoins. He has sent me 9 bitcoins. So how is this resolved? How is this conflict resolved? This conflict will be resolved same like in democracy. What more people will say, that will be added as the block. Okay, so here let's say that Srini and Surya are saying that $9 transaction has happened. Then that transaction, that block will be having $9. It will not be having $2. Okay, this is how basically Bitcoin network resolves the conflicts. If anyone wants to be the malicious party and want to change some transactions, even if you change, as your hash changes, your block will not be accepted by other blocks. Okay, only that block will be accepted. See, once a block is formed, it gets propagated, and that block will be accepted only if the hash matches with the hash that you have sent. Okay, so as soon as I find this nonce, what I do is that I sent this whole block of data to Surya. Now what Surya will do, Surya will put the same nonce and see if the H1 has come. Okay, he'll say that, oh yeah, H1 has come. So this is a valid block. So he'll also add it to his blockchain. In the same way, Srini will also see, he'll put the nonce in his block and he's getting H1. So what happens is the Srini will also add this to his block. So now let's say that Srini had changed this transaction to 10. Let's say he made it to 10. What happens is that if he puts this nonce also, he puts this random number also, the H1 will change. Okay, so he cannot add it to his blockchain. So this is how the conflicts are being resolved in a blockchain network, basically in Bitcoin. This is how it works. So any questions here? Any questions, guys?
Is that SHA function part of the Solidity program, Harsha? Or?
No. This is not a part of that. This is basically a part of it's basically part of setting up of network. Okay, in Solidity we won't be using.
Okay, I mean it's part of the blockchain technology. I mean, which was developed.
Yeah, so let's say that see, like for example, you have to set up a server to put an application onto it. No? So in the present systems, we have a server and we host an application on top of it. But for creating the server also, we have to have certain parameters, which the infra team does, So that setup, the server setup, in that case only SHA-256 is used. So here the blockchain is the server, correct? So in that chart this is used, but in our programming we won't be using it.
Okay.
Yeah. Yeah. So I think I'm clear. If any more questions, you can ask me. You can ask some questions about. If it is fine, we'll have a small break and we'll rejoin. Okay, we'll rejoin in 15 minutes. Fine. If any questions, you can ask me.
All right, let's join back after 15 minutes.
Yeah, yeah,
Cheers.
yeah. Thank you. Thank you. I'll be back in 15 minutes. Okay, we'll be meeting by, I don't know what is your time, at 15 minutes. That's it. Thank you.
This conference will now be recorded.
Hello. Hello, everyone. Is everyone there? Everyone's back, right?
I guess most of everyone, not all.
Yeah. If I think 8 people are also there, we can start. 7, 8 people. So just say yes if you people are there. Srini is there. Teja is there. And then Surya. Surya, are you there? Revant, Rajshekhar, Raj.
And Surya is.
Venkat is also there. Chalo, then we'll go to the next thing. So yeah, so till now we had seen the visual. I had actually shown you the concept and I had shown you on the board and all. So we can just have a visual how basically these blocks are being formed. So this is basically a website. You people can also visit whenever you time. You can go and visit and just play around with this. So see, let's say that this is the first block. Okay, this is a Genesis block. As I told, the first block is also called a Genesis block. And here, could you elaborate on the previous block edit of Ramit? One minute, Teja has a question. Let's take that question and go forward. Could you elaborate on previous block edit of Ramit as it is already completed and doesn't that mean it cannot be editable? And what if the edit had more than 10 MB? No, no. The thing is that once a block is mined, you cannot edit it. That's what I said. If you edit cannot be more than 10 MB, the block, first of all, block will not allow you to make an edit of 10 MB for the first place. And if you have the database and if you are trying to do it in your system, in your database, you are trying to edit it, your edited data will not be accepted by other blocks, other nodes. Sorry. So let's say that you have the blockchain with you and certain previously mined block, let's say that Teja is trying to change the data in already mined block. That is, let's say we are in the fifth block. The data in the fourth block, nonce is found, the mining is done, the hash comes out, everything is over. Now sixth block is running. Now let's say Teja is trying to edit a fourth block. So that fourth block data, if Teja, if you are trying to edit in your own database, that edit will not be accepted by other blocks. It's like the same way as I was telling in my first case, wherein it was between me, Srini, and Surya. Let's say that I wanted to be the malicious party and I wanted to change the transaction. Let's say that instead of $9, I write $2 only. When I write the $2, those $2 transaction, that list is not accepted by the other people. So in the same way, in the Bitcoin network also, when you're trying to edit your own database, the same block will not be accepted by others. So when it's not accepted by others, you are not part of the blockchain. Okay, so edit cannot technically happen. I hope I answered the question. So moving on to this, I think this website you people should also visit sometime. And this is nothing but this is just a small visual representation of how basically blockchain works. A small representation. Let's say Harsha to Surya, $5. Okay. So this is a transaction, right? I have written the transaction. See, as soon as if you can see what is happening. See, whenever I'm changing this, whenever I'm changing the data, you see, I've removed a space. This hash is changing. See, the hash is changing. So let's say that I just give a space, the hash changes. Okay. I make it I make it 2, the hash changes. So what is happening is that, see, this transaction has happened, and what happens is, let's say that the block is filled. Let's for ourselves, let's say that the block is filled. Now I mine it. See, 1276 is the nonce which I am speaking about. Here I spoke about nonce. If you remember, in the previous page, I had actually discussed about the nonce. So I put a transaction, I put a nonce, and see what is the answer. We have 3 zeros in the beginning. So the puzzle was 3 zeros in the beginning. Okay, the puzzle might change. It might be 5 zeros, it might be 10 zeros. So the puzzle for this block was, I should have 3 zeros in the beginning. The previous hash is this, the data is this, the data set is this, and I found the nonce, okay, with the computing power. Here actually I have not used the computing power, but in the real world scenario, computing power is used to find the third number, which was nonce, which I told. The nonce is nothing but this, okay. This is the data, this is the previous hash, this being the first block, it has no previous hash. Now let's take the next block. Let's add a new block. Here, I'll add Venkat to Teja, let's say $14 or something like that. I added this. So here what happens is, again a new block is found, but the previous hash is this hash. If you can see, the hash of this block has become the previous hash. Now again I mine it. The nonce is 4361. Here the puzzle is that first 3 numbers has to be 0. I got first 3 numbers as 0 when I put in 4361. So I think now we are understanding a bit how basically this blockchain works. This was one block. Okay, this was one block. This output, the cryptographic output, the hash was a previous hash for this. That is, this has the reference of this block. Okay, here again we have found the nonce, and once we go on, you can keep on adding how many blocks ever you want. So this is basically how blockchain works. I would suggest you people visit it after the class once and try out. So moving on to the next topic. Yeah, so basically I wanted to speak about cryptography. So cryptography is basically, so you can understand that blockchain is a what do we say? It's a mixture of cryptography, smart code, and mathematics. You can say all these three things mingled together has given birth to blockchain, and cryptography is actually the core of it. So there are certain things. So for every blockchain, whenever, let's say, we are designing a blockchain, or like whenever we are a blockchain developer, we should know certain things about cryptography. As a blockchain developer, you need not have to know deep about cryptography. There are very deep things in cryptography if you keep going on, but it's better we don't go down that lane. Just know what are the main things as a developer we need to know. So the first thing is that when we are choosing a cryptographic function, there are many cryptographic functions which are present, right? So the first and the foremost thing while choosing a cryptographic function is that it should be a public function, about which I have already spoken. So public function, what I mean is that, let's say that function was developed by an organization or by an individual, and that has to be open to the public to use freely, and has to be such that they can test it. Okay. So a function which is publicly available is called as a public function. So like anyone can develop, even you can develop it and make it public. But then when we as a developer are choosing some cryptographic function, we should make sure that it's a public function. It should be heavily tested. Okay, and then it's better it has at least what do we see, at least a time span of 10 years, because in 10 years the technology rapidly changes, and then then we understand whether a cryptographic function can be broken or not. So but then now the technology is moving even faster, so maybe the years will reduce. But it's better if we take 10 years. So SHA-256 is one of those. Since last 20 years there has been no much issues with it. So we actually chose SHA-256 for the Bitcoin blockchain, but there are certain other properties associated with the cryptography function. So the first of those is it should be deterministic. So what do you mean by deterministic is, let's say that I have a function, right? I have this function SHA-256. What I mean by SHA-256 is, let's say that I write Harsha, okay, and I get some output. Let's say that I get output. I get an output 1. Okay, let's say that I get output 1. Let's say now I change it. I put this as I put it as Teja. Once I put this as Teja, what happens is the output should become O2. It shouldn't be the same. So whenever I'm changing the input, the output should be different. So that is what is being deterministic. Deterministic means even if I change t from small t to capital T, the output should be something else. Output should be some O3. Okay, so that's what is called as deterministic. Okay, let's say that Teja output was O1 and I put Venkat and it becomes O2. So deterministic is nothing but for different input, output should be different. No two inputs should be having the same output. That is the first point. Second thing is quick computation. So basically in software, we always speak about scaling. We always speak about speed. For customer experience, speed is the most important. The so the page reload speed should be in milliseconds, and I think you people might have worked with those fields where we you know improve the scaling of a particular project. So yeah, so whenever you're using a cryptographic function, we should also see that how much time is it taking to give an output. It should not take a lot of time. It should not take 1 hour to give an output. So it should be quick. So this is the second one, quick computation. The third one is pre-image resistance. Okay, so pre-image resistance is nothing but if I give you the output, let's say that I do SHA-256 Teja, I take this O1, okay, I take this O1 and give it to, let's say, Pramod. Let's say I take this O1 and give it to Pramod. Okay, now with that O1, Pramod should not be able to know what the input is. Okay, that is called as pre-image resistance. I think the terminology only tells you that thing. Pre-image resistance is nothing but once I get an output, if I give that output to anyone, they should not know what the input is. Okay, that is the sum of the thing. So there are different cryptographic functions as such. MD5 is one of the oldest, but this has become obsolete right now. No one uses it. MD5 is also cryptographic. SHA-1 is also a cryptographic function. SHA-256 is a cryptographic function. KESAC-256 is also a cryptographic function. But the most secured of these all is SHA-256 and KESAC-256. SHA-1 is not yet that secure. So these are different cryptographic functions, just to highlight to you people. Now I think I made these things clear, and then now moving on to the next topic. So there is something which we need to understand. So we actually spoke about Bitcoin till now, right? We spoke about Bitcoin. So like in dollars, I think you have cents, right? So $1 is equal to 100 cents, right? $1 is equal to 100 cents. So in the same way, in the Bitcoin network, one Bitcoin is equal to 1 into 10 to the power of 9 Satoshi. It is named after the founder who has actually designed this particular cryptocurrency, that is Satoshi Nakamoto. So Bitcoin, its minimal value is 1 into 10 to the power of 9 of Satoshi. That is, what we can say is one Bitcoin can be split into 1 to 10 to the power of 9 Satoshis. Like $1 can be split into 100 cents. In the same way, one Bitcoin can be split into 1 into 10 to the power of 9 Satoshis. Okay. So we spoke about Bitcoin network. But in this course, we'll be going through Ethereum blockchain. Okay. So Ethereum blockchain. So why did basically Ethereum blockchain come up? What is it? Let's look into it. So Bitcoin was basically designed to, transfer value, that is transfer amount, all these things without a third party. But then we cannot write code onto it. Even if we write code onto it, it is not designed to support developers. Okay, it has been designed to support transactions. Okay, it is not designed for developers to write a code and put it onto the Bitcoin blockchain. So what happened was there was a 19-year-old guy called as Vitalik Buterin, and this guy was born in Canada. I think you will have heard of him also. This guy was born in Canada, and when he was 19 years old, he created a blockchain called as Ethereum. Okay, and Ethereum, the value token within the Ethereum blockchain is Ether. The value token within Bitcoin blockchain is Bitcoin. Correct. So within Ethereum, it is called as Ether. And then what he has done was he made it possible for the developers to write code and put onto it. Okay. So let's say we wanted to do some bidding. Let's say I wanted to put my laptop on sale, or let's say that I had some precious item with me and I wanted to put it out for bidding so that people can bid. So in this case, presently what happens is we use a third party platform wherein there are where we list our particular property, and people bid for it, certain percentage goes to them, and then the remaining percentage comes to us, and all these things. So we have a third party involved. But then with the blockchain technology, basically with Ethereum, what has made possible is with the code itself, you can put a code onto the blockchain, and then the blockchain will itself collect money, as well as transfer money to your account and transfer the ownership of property to the one who has bid it, about which we'll be learning through the course. But as an overview, what basically Ethereum has the capability of actually removing the third persons, like the third party. So with the code, we'll be able to trust each other because Bitcoin, the blockchain is about trust. It is bringing in trust because it is immutable and all these things which we have spoke about. So as it brings in trust and all these things, we can write a piece of code and put it onto the blockchain, and we both can do business without a third party. So this is basically a concept on which Ethereum was developed. Ethereum was developed with a concept such that the developers can write code and put onto it. Yeah, this was made in 2014. Okay, this was made in 2014, and the value token within the system is called as Ether. Okay, and one Ether is equal to 10 to the power of 18 V. Okay, so like we have one Bitcoin is equal to 10 to the power of 9 Satoshi, or like $1 is equal to 100 cents. So in the same way, one Ether is equal to 1 into 10 to the power of 18 V. So the smallest value, what you can say, the smallest value in the Ethereum is V, and the smallest value in Bitcoin is Satoshi. So any questions here? Any one of you can ask questions to me right now. I have 2 minutes or 1 minute. Hello.
I have a question.
Yeah, ask it.
If suppose two nodes giving the same input, are they going to get the same output?
Yeah. Yeah, like in terms of what you're saying?
Suppose the previous screen was showing Shasha 256 and Teja and equal to 0, 1. And if the two nodes giving the same, SHA 256 Teja equal, then they get the same output 0, 1?
Yeah, yes.
That's going to duplicate, right?
No, it's not duplication actually. Duplicate as in? I didn't get you.
A duplicate of a hash, right? That is the hash tag, right? 0, 1 is actually the hash tag,
Correct,
right?
correct. Yeah, so that's what. So every node will be having a duplicate of whole database, right? Any transaction happening in that network, every node will be maintaining it. Every node will be maintaining the same data.
But the data will be synced with all the nodes, right? And if it is
Correct.
having duplicate, how that is going to work?
Work means what is the issue with that?
Suppose if the two nodes given the same time, same output, and if it is trying to sync the first node to another node, is that giving any issue?
No. Basically, no. It doesn't give an issue. So what happens is that so we cannot say that we are sending one data to one node. What happens is that once I do a transaction, it automatically gets propagated to all the nodes. Okay, if you have a good connection and if you have what do we say? If you have a perfect connection with you, what happens is that you can get all the transactions with you. But if you are a node, you are not having proper internet connection, then latency issues can come in. Then what happens is you need to synchronize with the blockchain first, and then start mining. So there won't be any issues of loss of data or something. That loss of data can only happen only if your connection is not proper.
Okay, but this always happens, right? The latency and the connection is we cannot determine all the time. It can be, it always be there, right?
But then the resistance factor is too high. So you want so here there if there will be a bit of issue also, it's not a big deal. So when I do a transaction, it gets propagated to everyone. Maybe there are certain chances about which we'll learn. If there is latency issues, what happens and how blockchain deals with it. About that we'll learn in the coming classes. Okay.
Okay. Thank you, sir.
Yeah, sure. So no more questions, right? So I'll move on to the next topic. So this was cryptographic functions. Now let me come to the addresses part. So yeah, so you might have heard that blockchain is basically a replacement for the banks. We won't be needing banks anymore and all these things. Maybe you might have heard, even if you have not heard. If you come to the blockchain space, you'll be hearing these things more. So let's just make an analogy like how basically the blockchain is same as the what do we say? Same as a bank, or like we'll make certain analogies here. Okay, just wait. So, so in basically in blockchain, we have a concept called as public key and a private key. Okay, any blockchain you go, your identity on the blockchain will be a public key, but to unlock your funds or to do transactions, you need your private key. It is same as public key is same as a bank account number, okay, and the private key is same as a password, okay. So I think when you go to an ATM to withdraw cash, or when you swipe your card somewhere, you just put in your PIN. Yeah, nowadays even that is also gone. People just scan and then pay. Okay, that's fine. But then generally speaking, when you go to a bank or somewhere like that, you have your own password, you have a debit card, you have an account number from which you put a password and take the amount. So in the same way, in the blockchain space, we have a public key and a private key. Okay. Now, before going to the next thing, I wanted to just brush up our basics, which we learned in engineering, or maybe we might have not touched. So certain basic stuff I wanted to touch. I wanted to, one yeah. So if you see, 8 bits is equal to 1 byte. I think this most people know. 1 byte of data is equal to 8 bits of data. Okay. And 1 byte is equal to 2 hexa characters. Hexadecimal characters. So I think, can anyone tell me the difference between binary and hexa? Can anyone tell me the difference between binary and hexa?
Binary is 0 1 stored always, and
Yes,
hexa
correct.
is like I believe 16 characters. It's 0 to 9 and A to F.
A to F, correct, exactly. So yeah, so the thing is that I'm just making the comparison here is that 8 bits is equal to 1 byte, and 1 byte is can also be represented in 2 hexadecimal characters. So how can we do that? So binary is basically 0 1, zeros and ones. Okay, but hexadecimal will be A B C 1 to 9 and A to F. Okay, that is 15. That is 0 to 15. Okay. So how did I say that? Can anyone tell me why I'm saying 1 byte is equal to 2 hexa characters? Can anyone explain? Do you understand this thing that 1 byte is equal to 2 hexa characters? Hexadecimal characters I was saying. It's not hexadecimal characters. Yeah, why is it 1 byte equal to 2 hexa?
Because one hexa is stored 4 bits.
Very good. Very good. So put into perspective, just so that we all are on the same page. I just wanted to say, see, like in binary, if you remember, we had 8421, correct? If I wanted to, if I wanted to represent numeric one in binary, what I used to do 0001, correct? If I want to represent 3, I do 0021. If I want to represent 15, I do 1111, correct? 1111. So now why I say that 1 byte is equal to 2 hexa. So here you can see that we have 1111, we have 1111, we have 8 bits, which is nothing but 1 byte, correct? But this 1111 can also be represented as F in hexadecimals, correct? So 4 bits can be represented by one single hexadecimal character. In the same way, 1111, this can also be represented as F. So that's why I'm saying that 1 byte can also be represented in 2 hexadecimal characters. I think this thing clears things for you people. Any questions you can ask? I'll be moving forward. Okay. We have, that's what I'm saying. What I'm saying is 1 byte can also be represented 2 hexacharacters. So just keep in mind, so that it will be useful for the next topic which we are doing. So right now what I was speaking is that we have a public key and a private key. But then it is also important for us to understand that how basically this public key and private key are generated. So right now in banks, what is happening is that they have a software. It generates a random, unique. In India, basically, it's a 16-bit digit. Yeah, it's actually 16-digit account number. On the card, we have 16 digits. That is card number, I guess. And account number is, I think, 20. I don't remember properly. So this is actually generated by a software, which actually generates a unique key every time. Correct. So, but then in blockchain, how do we generate a public key and a private key? So this will be helpful to you in the future. If anyone asks you questions, you are trying for interviews, or even if you're trying to interview someone for a job and all these places, this will be very helpful. So how are the addresses generated basically? So there is an elliptical function. What this does is it generates keys. Okay. What it does is whenever you call this function, it gives you a 32 byte. 32 byte is nothing but 256 bits, right? 32 into 8. 32 into 8 is 256 bits. Okay, 256 bits is nothing but 32 bytes. Correct? So 256 by 8, that is will be giving you 32 bytes. Correct? So what it does is it gives you a 32 byte string. Okay, binary string it gives, or you can also write it as 64 hexadecimal characters. As I said, 1 byte is can be represented in 2 hexa characters. 32 into 2 is 6 hexa characters. So in our blockchain terms, we will always be dealing in hexa, that is 0 1 to f. We won't be having 0 1 0 1. We'll be having 0 to f. Okay. So what it does is elliptical function generates a key which is of length 64 hexadecimal characters. Okay, it generates a key. Then what happens is that this 64 hexadecimal characters are put into another function. Okay, it's puts into another function and it gives one more 64 hexadecimal output. Okay, so this function differs depending upon the algorithm you are using. Okay, this function can be changed. So that is the reason why I put it in a generic way. So how it happens is an elliptical function generates a key of hexadecimal of 64 hexadecimal characters. That is a private key is generated first. That is a password is generated first. Then this key is put into a function and it again generates another 64 hexadecimals output, a new 64 hexadecimal output. Then what happens is that the first 24 characters of the hexadecimal are deleted. First 24 characters of the hexadecimal are deleted and the remaining 40 hexadecimal characters are taken as a public key. Okay, this is how it happens in Ethereum. In Ethereum, what happens is a private key is generated and from that private key, a public key is pulled out. This happens everywhere. Any cryptography in anywhere, in even whenever you're working in future in cryptography, encryption or decryption or anywhere, first the private key is generated and then the public key is generated. The length might differ, but here we are speaking about Ethereum blockchain. And in Ethereum blockchain, we have a private key of length 64 hexa characters and a public key of 40 hexa characters. What happens is that once this private key is put into the function and you get 64 hexa characters, the first 24 characters are deleted and the remaining 40 characters are only taken as the public key. So any questions here? If you have any questions, please ask. I don't see you people asking questions.
Yeah, hi, Surya. Yeah, I mean, what are these addresses used for? Is it like for wallet or bank account number? I mean to say, for wallets, is it like a platform dependent or is it like, I mean, user dependent or how? I mean to say, Bitcoin will have a different public key and Ethereum can have a different public key. And is it like for one user, it will be one public key across the entire blockchain space, or is it going to be like, again, it varies from platform to platform?
Very good question. Very good question. So the first one is the public key will vary for person to person. Sorry, person to person. It will vary from platform to platform. Yeah, for Bitcoin you'll be having a different public key. In Ethereum you'll be having a different public key, and every public will be accompanied by a different private key. Everything will be having its own private key. And along with that, if you want to do any transaction on Ethereum network, you need to have your own public private keys. If you don't have your public private keys, you won't be able to do a transaction. Just like you, if you don't have an account number, you won't be able to transfer account to some other guy. If someone has an account number, you can't. If you don't have an account number, you can't use the bank services. So in the same way, blockchain services or Ethereum, let's say for that blockchain, if you want to use those services, you need to have an account number there. So account number here is nothing but the public key, and it is accompanied by a private key. Every transaction will be signed by your private key here. Yeah. Did I make it clear, Surya?
Yeah, I mean, yeah, I got that. But I mean to say, do we need a public key and private key to make any transactions? I mean, what?
Every time.
Okay.
Yeah. Any more questions? Any more questions, guys? Okay. Any questions? No more questions? Okay, now we have understood what this says. We have understood what this one is done. Yeah, this one is done. Okay. Okay, guys. So if any no questions are there, I'm moving on. I'm moving on to the next topic. Yeah. So now we'll be speaking about a concept called as tail, orphan, and uncle blocks. Okay, this is a very good concept. It is very interesting. And then yeah. So right now we spoke about latency and we spoke about some things, right? So basically, Bitcoin being a public network, anyone can be a part of that network. Anyone can become node. Anyone can keep downloading the data. Okay, everyone will be maintaining their own database, listening to the transactions happening in the network, and writing it to their databases. Everyone will be doing. But there can be certain situations. Let's say there is someone sitting in Africa, okay, and there is someone sitting in America. Okay. Now we have, so let's say that block one was done, block two was also done. Okay. This here I'm actually representing a blockchain. Let's say this is block number one, this is block number two. Okay. Now let's say that someone is sitting in Africa. There is a node in Africa. There is a node in America. Okay. Let's say I'm sitting in Africa and Surya is sitting in America and he is also mining. I am also mining. Now what happens sometimes is that the transaction done by someone in Africa will reach me and it might not reach a node in America due to latency or due to something, due to some network issues. What will happen is that that particular transaction might not have reached. Though the transaction is valid, that transaction might have not reached the American guy. Okay. And the African guy would be receiving the transaction. And as usual, he'll add the transaction to his block. Correct. The number three block, he'll add his own transaction. And American guy would have not added the same transaction. Okay. Now here what is happening is this is also a valid block. Okay, this is also a valid block. And number four is also a valid block. No one has done a faulty transaction. Transactions are right, but the content, the one transaction differs. American guy is having a different transaction. African guy is having a different transaction. Now, how will the blockchain network solve this issue? Now, there are two versions of truth, okay, and both the versions are right. Okay, there are two versions of truth, and both the versions are right. How will it be solved? So, what happens in this case is the person who will be creating the next block first, that is, the person who will be finding the nonce, the puzzle of the next block first, his block will be added as the main blockchain. Okay. Now here what has happened, African and American guy have a conflict. Now the network can give a reward to only one guy, correct? The network should give the reward to only one node, but both the nodes have valid blocks. Both the nodes have found their own respective nonces. Okay. Now how will this be resolved? So this will be resolved by whoever will mine the next block first will be becoming the part of the main blockchain, and the valid block, though it is a valid block mined by someone, and if he is not able to mine the next block first, his blocks will be removed. Okay, so let's say that in this case, let's say the African guy has mined a new block. Okay, next block first. After three, in the next block, African guy is able to mine the next block first. Then this becomes the part of the blockchain. 1, 2, 3, 5 will become the part of the blockchain, and the number four block will be called as a stale block. Okay, stale block. So this block will not be added to the blockchain. This block will be removed. Even the American guy has to remove it and again download these two blocks and then fight for the next block. Then start mining the next block. That is the seventh block. This number seven block, again American guy should delete these two and again come here. Okay, so the block which was the block which was removed from the blockchain, though it was correct, that is called as a stale block. So are you clear about this? Like any doubts here? Any one of you, Surya, Srini, Srikant, Devant, Srini? Yeah.
Yeah, I think we're good. So technically, you will remove block number 4 and replace with 3 and 5, is it?
Yeah, 3 and 5 will be added. Correct.
Okay.
Correct. And how it will be added is the person who will be mining the next block first. If there are two versions of the truth, and the person who will be mining the next block first will become the part of the blockchain. The person who was late or who was not able to mine the next block first will be removed. And the block which that other person had mined is called as a stale block. That will be called as a stale block. Okay. So stale block is nothing but, the block which is no more in the parent chain. It has been removed. That is called as a stale block.
But it
Okay.
doesn't have any financial impact, right, for block number 4, because he's
Yeah.
replacing with number 3.
Yeah. So there will be an impact. So what will be the impact is seen here? The transaction, the let's say here one transaction difference was there, right? Here,
Yeah.
this year there will be only one transaction difference. Okay. So the one transaction which is actually sitting in the American block, no, that will get cancelled. That block will get cancelled, the transaction will get cancelled, and you have to reinitiate the transaction. Your
Oh,
balance will be same. The transaction has to be reinitiated.
okay. So you just have to reinitiate the transaction, but he
Yes, yes,
doesn't lose financially.
he doesn't lose any financial. It
Okay.
will be he has to reinitiate. Yes,
Okay.
that's it.
Good.
Yeah. Surya, you have some question, Azir?
Yeah, I mean, how this American guy will come to know? Is it like they'll get to know that? I mean, after generating the block 5, how this block 4 guy will come to know that he is out of sync or he is a stale block? Is it like the network communicates to him that he is out of sync with the main blockchain,
Yeah,
or
correct. So the software itself will suggest you that you're out of sync.
okay,
Then he comes to know that he has mined a stale block.
okay, got it.
Yeah. So now the thing is that the American. So now what happens is that whenever someone mines the block, right, that block is propagated to other nodes. So like I am a guy, Harsha has mined the block. I'll propagate it to Surya. I'll propagate to Srikanth, Revant. If all of us are nodes, I'll be propagating it. Okay. I'll be propagated to the. I'll propagate to all the nodes, and they'll check the nouns, and they'll see that okay, this is a valid block, and they add it. This all is done by the software itself. It is not done manually by anyone. Okay, so now what happens is American guy, even though he has become a stale block, he might have mined one more block, but this number 6 block might have been delayed from number 5. Number 5 was mined first, but number 6 was also mined, let's say. Now what happens automatically is that this block also starts getting propagated to other blocks. Now let's say this block number 6 reaches the African guy, okay, and this African guy will see this block and he'll say that, hey man, this parent only I don't know, because the number 4 was only not included in the blockchain, right? So it would be carrying the previous hash, correct? It will be having the previous hash, and this hash was not there in the block. So African guy, what will do? He'll just not accept this block because the previous hash is only not there. He doesn't know who the parent of this block is. The number 6 parent is number 4, and the number 4 is not there in the African guy's blockchain itself. So for him, this block becomes an orphaned block, correct? So you understand the difference between an orphaned block and a stale block? Can anyone explain me briefly the difference between the orphan block and the stale block? Any one of you, please. Yeah,
So
Venkat.
when the block 4
Uh-huh.
becomes a stale and next block is generated with a new hash based on block 4,
Oh,
right?
correct,
When
correct,
the block 4 is taken out, there's no
correct,
reference for the block 6. So which
correct,
becomes there's no you can't relate to the previous hash or parent block.
correct, correct,
So
correct,
so that's why it will become ARPAND. We don't know where to set, where to relate.
correct. So it becomes an orphan block, right? Okay. Okay. So now we have understood these two concepts. So this is only to this uncle and this, sorry, the stale and the orphan blocks. These two things are only corresponding to the Bitcoin blockchain. Okay. It is not so only to be in Bitcoin. We had this issue as this was the first application. They made this whole concept of stale and orphan. But this issue is not there in Ethereum blockchain. So we also need to understand that Ethereum is a different blockchain. Bitcoin is also a different blockchain. Okay. These two are separate. Here I have spoken about Bitcoin, okay, how much stale blocks and orphan blocks. This is information for you people. And then now I go on to the next thing. So what happens is that what Ethereum engineers have done is, what is happening was many times what was happening, someone was expending so much energy, mining a valid block, but he was not being paid for it. So it is a loss to the nodes, right? People are losing money. They are spending so much energy and their block is only not getting added. So many of the nodes might end up mining a stale block, right? Like the chances becomes more, if there are latency issues or like something, the chances of mining a stale block becomes more, correct? So there is a lot of financial issues that the block nodes will face. Okay, so for that to tackle that, what Uncle Blocks, what Ethereum has done is that. Yeah, any question? Anyone has a
So,
question?
what is the percentage of getting this stale or orphaned block?
It is very lesser. It's in 0 point something. I don't remember the correct percentage, but then you can just check about it. Or else I'll tell you next time whenever we meet.
Arsha, sorry, can you refresh my memory on the stale block? Is it after transaction 2 between 3 and 4? If 3 guy can mine the next one 5, does 4 becomes stale?
Yes, yes. If 3 mines the 5, then 4 becomes stale. Yes, correct.
Okay, so if you, because in any transaction you'll have at least 2 parties involved, right? And in which case, is it always like one guy will have mine, the other guy will become stale, or in what scenarios a block can become a stale when transactions are happening between 2 parties?
You see, the transaction might happen between 2 parties, or within one transaction, you can send it to 3 people. That is not the thing here. Here I'm
Okay,
speaking of blocks. Here I'm seeing a block. This is block 1, block 2. These 2 blocks are there with the African guy as well as American guy. Okay.
okay,
Now we have come to the third block. Okay. In the third block, what happened? Some African transaction was included here, and that African transaction couldn't reach the American guy. Okay.
oh, it
Now
couldn't,
you
okay,
couldn't reach the American guy. American guy is also a node. He also has all the blocks. You're now coming to the third block. This is not
okay,
block number 4. Let's say this is also the third block. Both are at the same level. Okay, that's why I've
okay,
split. Okay, now what has happened is now there are 2 versions of truth. That is, this guy is saying that this is the version of truth. American guy is saying that this is the version of truth. How will it be resolved? It will be resolved when whoever will create the next block first will be becoming the main chain. The longest chain becomes the main chain.
gotcha,
Okay. Here African guy has created the 5th block, so this becomes the main chain, and the 4th, this American guy gets a notification that you're out of sync, and then he understands that he has mined a stale block. The chances of mining a stale block is actually 0.00 something. Okay, but the stale blocks are still being mined as we speak. Okay, there are chances that you mine a stale block.
gotcha. Okay, cool. Thank you.
Yeah. Yeah, Surya or someone is asking. Teja, who was asking the question? There's some question, I guess. Okay, chalo. I'll move on to the next thing. So this was the issue basically in Bitcoin network. People were so many other nodes were mining stale blocks, and they were not getting rewarded for it, and so those issues were there. So what these people have done is what the Ethereum people have come up with a different concept. What they have done is, let's say here also 1 and block 2 are there. Now in the third block we have again 2 versions of truth. Okay, and generally in these 2 versions of truth, what happens is not all transactions are different. Maybe one of those transactions will be different, or 2 of those transactions will be different. Okay, so how to include those 2 transactions? How to include those 2 transactions in a stale block? How to add those 2 transactions, to the blockchain? How do we do that? So how do we do that is that, so let's say there are 2 transactions which are different from the number 3. Now let's say that in block 3, block block so the difference, so in, let's say in the block number 4, block 4 we have 2 transactions, so block 3 minus block 4, block 3 minus block 4 is 2. Let's say that it is 2 okay. So there is 2 transactions. The difference between both the blocks is 2 transactions. What Ethereum people have done is they would remove 2 transactions from here and add it to the next block. Okay. So let's say the number 3 block has been mined, and in the number 4 block we have 2 transactions. Okay. So what happens is these 2 transactions are picked up and are put into the next blocks. They are accommodated into the next blocks. They can be, and there is a rule for this, they can accommodate, the transactions which are in the let's say the other chain, let's say this is the American chain, let's say the transactions in the American chain, the transactions can be included into the main chain until the next 7 blocks. Okay, until the next 7 blocks, the transactions can be picked up from the 4 and they can be included here. Okay, so any questions here, guys? Like, are you understanding what I'm trying to say? So the difference between the yeah, Venkat, please, Surya, yeah, continue.
Is it block 4 minus block 3 or block 3 minus block 4? Those two transactions.
Anything, same. So the difference is 2 transactions. That's what I want to say.
Okay. Okay.
There is a 2 transaction difference. What happens is that those 2 transactions are removed from block 4, and these 2 transactions are removed from block 4, put into the next block, that is number 5 and number 6. They'll add it. You can add it till the 10th block. That is, I'm saying 3 plus 7. You can add the transactions from here to the next 7 blocks. Even if there also you are not able to add it, if these transactions are not added, those transactions fail and you have to reinitiate the transaction. And there is no financial loss. But then this is the advantage of the Ethereum. In Ethereum, you won't be having, there are no chances of your transaction ending up in a stale block and you reinitiating a transaction. Even if it is in a stale block, those transactions are picked up and are put into the next incoming blocks. Clear about this?
So why would there will be difference in the transactions? Because the blocks are same, right? So every block will have same set of data. I mean, not every block, but the block will have same set of data.
Yeah, it should technically have same set of data. It should technically have same set of data. But I was speaking about comparison between an African node and an American node. Well, let's say that American node is not receiving a transaction from the African guy. Okay, and he couldn't include this transaction. That's what I was
Okay.
thinking.
Okay.
Yeah. Technically, they should be same, but sometimes there are chances of latency. That's what I'm saying. So to tackle that, this is how Ethereum tackles, and that is how Bitcoin tackles. The previous page is how Bitcoin tackles, and this is how Ethereum tackles. And these blocks are not called as tail blocks; these are called as uncle blocks. Uncle blocks means, let's say that this is a family tree. This is a family tree, and someone, our cousin, becomes an uncle, right? So someone from outside our family, either from our family itself, but then they become an uncle. So that's why they're saying that this is an uncle block. The transactions in the uncle block will also be included into the main chain. So this is how Ethereum, deals with it. So any questions here, please?
Yeah, hi Harsha, Surya here. Yeah, I mean, is that orphan block also? I mean, in Ethereum, they handle the situation of orphan blocks as well, or is it just the stale block up to the stale block level?
It's up to the stale block only. I don't think so in this. Yeah, there is no concept called as orphan block.
Okay, I mean to say, in the previous scenario, if the same situation happened that we discussed, let us assume we mined the stale block and we moved on to the orphan block. So
Correct,
what happens in the scenario in the Ethereum blockchain?
Yeah, in the
So
Ethereum blockchain, what would happen is that if again one more block was mined, what will happen is again those transactions have to be added to the next 7 blocks. That is from, let's say, from number 4 to 7 till the 11th block. So one more block, if it is mined, till that time they will come to know that they are out of sync. But then even though if they mine one more block, those transactions will again be picked up and will be put into the next 7 blocks.
Okay, I mean, when it comes to that, I mean, currently we are looking for the differences between block 3 and block 4, correct? So, so if there is an orphan block, I mean to say, in which of the block they will look for? Is it like from block 3 to current, or how does that work out? I mean, if there is a solution in Ethereum blockchain for that? For orphan
Yeah,
block?
they will look from the block 3 itself. No, block 3 is mined, right? So block 3 is mined. So block 5, from the block 5 they will be looking. So let's say that a block is mined here. Here, let's say 1, 2, 3, 4. Let's say this is 5. Okay, this is 5. Okay. And you're saying here one more block is mined here, no? You're saying here an orphan block is mined. So
Yeah.
this will be compared with the number 5. This will be compared with the number 5. From the number 5 on, it will be checked that how many transactions are different. And like obviously maybe some transactions will be different. Again, those will be added here. Yeah, this is how it does here.
No, I have a question here. See, in uncle blocks, what is the possibility of happening of this orphan block? So where, if you go to the Bitcoin network, so if you get a stale block because of there is no link, so that's why we are getting a orphan block, right? So here, when you get a stale block, it is automatically redirecting to other block. So where is the question of orphan block here?
It's not redirecting, it is picking up the transactions and putting them there. You have to understand it's not redirecting the whole block into the blockchain, it is just taking the difference of the transactions and putting them here. So there is always chances that you created an uncle block and you can mine one more block on top of it, obviously. So here there is no concept called as half on the block because this block is not being propagated everywhere. This block is not being propagated everywhere. The transactions from here are being cooked up and are entered into the blockchain.
Harsha, I think we need to put an example with the transactions and then build the blocks so that way, everyone can understand. Yeah.
I don't think so this can be done here. So for that we need to write a code and show all those things. So I don't think so that can be done here. But then conceptually you need to understand like what is happening. So the thing is that the transaction here there is no concept called as uncle block. Yeah, accept it. And then if one more block is mined, here the blocks are what do we say? The uncle block is not propagated. The transactions are only picked up and put into the other blocks. It's a very small concept. It doesn't need any more explanation about it. Hello. Hello, Surya. Yeah.
Yeah, I mean, I just want to say that I got it.
You got it? Okay, sure.
Yeah, yeah.
Venkat will surely try to do that. Let me think about it, how to put it, put it across. At present, I do not have any visual. I don't have anything to show you. So I can't mine an uncle block for you and show it. Okay. But then,
Okay.
have the concept in mind. Just understand that uncle blocks is for Ethereum and stale blocks is for the Bitcoin. And in uncle blocks, what happens is that the transactions are just hooked up, removed, and put into the main blockchain. And yeah, that's it. Yeah, Srini, you have a question? Yeah.
No, I was just suggesting maybe in the next session if you can come up with some samples because team would like to see it. That would be good. I know you may not have right now, but if that's something possible for our next session, maybe 2 minutes,
I
we can
try.
have everything ready. Yeah,
I
yeah,
can guarantee Srini, but then I can try. Okay.
fair enough. Thanks.
Yeah, because I just need to think how to bring this data out of the blockchain because this is a whole public network, and then I need to first synchronize and then show it. So it's not
Understood.
that easy as you think. Yeah.
No, understood. I mean, yeah, I got you. Maybe in your sandbox or something, probably some screenshots for that. That would help.
Sure.
Okay, thanks.
Yeah, Harsha, it looks like Srini is asking, like, I mean, the first slide which we have seen where we have recorded some transactions, right, from Harsha to Surya, Surya to Srini, something like that. He's asking for to give that depictive diagrammatic explanation for this one, not exactly to reproduce the blocks and all. It's just a depictical explanation. Let us assume in block 4 we have transaction 1, 2, 3, which are those things. Those 1, 2, 3 will come into block. That's kind of explanation I think Srini was expecting from you. Instead of
Okay.
programming everything, I mean, he's not expecting the programming stuff, I believe, but he's expecting like show it in terms of the picture here.
Okay.
Correct me, Srini, if it's something different.
No, that probably makes sense, but I leave it to Harsha, whatever is the best way to do it. Like, you don't have to solve that puzzle right now, Harsha. Let's move on. You may have some agenda right now to complete for today. Let's move forward with that, but keep that in mind. Either you do what Surya suggested or whichever is the best way. You can pull something out of your sandbox, that's fine too. But let's move on.
Sure. Yeah. So now, before this, one minute, let me check this. What needs to be? Just a minute, I'll be back. Now, building. Hello. Yeah, so like right now what we'll do, one thing is that we'll do a MetaMask installation. MetaMask is basically a plugin, okay, which connects to the Ethereum blockchain, and you can basically send ethers to people. Okay, so we'll do that for now. I would ask you people to open Chrome, Google Chrome, open the Google Chrome, and then I want you people to type MetaMask. Yeah, hello.
Yeah.
Yeah, just type this thing and do add to Chrome. This is a plugin. Yeah, so have you people added? Like, please add it.
Just click on add to Chrome. That's all.
Yeah, that's it. That's it. Yeah.
Okay.
Yeah, then open it. Just click on the. If you'll get some fox symbol over here. See a
It's
fox.
just it says create some password and all those things. Do we have to create
Yeah,
that?
yeah.
No.
Please click that and remember the password, please.
Okay.
You do continue and scroll this down and then accept.
Yeah.
So here you will see like secret backup phrase will be the heading, and there you can click to reveal secret words. You know, copy it, copy them, and paste it in some notepad. This will be the recovery. You can recover your account. You can recover your account by using these 12 words.
Oh, it's like a string of sentences, is it? Two,
Yes,
three
yes.
lines. Okay.
Basically, technically, this is called as a mnemonic.
Okay.
So yeah, just I think once you people reach here, tell me, okay, all of you. Once everyone is done, please say yes that you have reached, and then I can move forward also.
Harsha, I guess we can only create one password per system, correct?
No, no, you can remove this extension and again, you can again add the extension and then you can create one more. So, but then just remember the password, it would be better.
Okay.
So can we access this add-on from other systems? So suppose if I add-on to my current system, so if I want to access same address, MetaMask, how can I access?
How will you do that? Teja? You got those 12 words, right? You got those
Mhm.
12 words. You have an option called as import seed. Okay, when you do it, there is an import seed, and in that you put this seed. Once you put this seed, you'll get your whole account.
Oh, okay.
Yeah. I'll explain you how is this is basically happening. This is called as a mnemonic based public-private key generation. This is a process. Okay, what happens in the background, I can tell you. Yeah.
Yeah, I'm already using, for transferring, and so I'm, I know, but
Oh,
I don't know what happens in the back end. So I used for buying of ICOs and all the stuff. Yeah.
oh, great, great.
Yeah.
Did you buy it in the bubble?
Yeah.
So I'll tell you what generally happens here. Did you all of you copied the secret words, right? So
Yeah. Yes, I copied you.
I'll just
Yes,
go
yes.
back to our class which I had already taught. Yeah. So here, when you come here, so here I told that there is an elliptical function, right? I told this generates a private key. So what happens in the background of MetaMask is what it does is these 12 words. Okay, these 12 words are basically put into this function. Okay, and those 12 words are random every time, and this random words are put into that will generate the private key, and that will give the public key. Now you ask me that how will I use the same address in a different system, right? There again, what will happen is when you download the MetaMask software, that is once the plugin gets installed in your Chrome browser, it's not a plugin, it's called an extension. So once the extension is downloaded into your Chrome browser, it will have all the code in its background script. Okay, if you have worked with extensions, you would understand. So in extension, we have a background script. So in the background script, you will be having all this code. Okay. So what happens in that code is that the 12-word mnemonic is put into this function. That function gives a private key and a public key, and that you can see in your front end. Okay. So did you understand what I was trying to say?
Yeah, I got it.
Yeah. So now what you can do is you can reveal these words, and then just control it. So let's copy the copied ideas. Control C. Now press next. Okay. Now press next, and select the words in the same order. Select the words in the same order as the sentence was given to you. This is done by MetaMask such that they understand that you have saved these 12 seeds. See, in MetaMask, even if you are not connected to this particular plugin, this particular extension is basically in-house. It will be in your browser. In no way MetaMask is storing any of your data. Okay, that is the advantage of MetaMask. It has given a Chrome extension, and no, there will be no calls made to the server as such. Okay, so the whole this public key, private key, even the MetaMask people also do not know what your private key is. That is the advantage of this plugin. Now select the words in the same order as the sentence was given to you. Okay, like for me, it is Rose Fiscal Alcohol Zone. It will be uh, Rose Fiscal Alcohol Zone, then twice slice size slice holiday, Rose Fiscal Alcohol Zone, twice slice holiday, test globe glass amazing bone. So have you done this? So once you do this, once you select it in the same order, confirm it. Once you confirm it, your account is ready. Okay. So tell me once you're done. So I've got this. So here you can see I have, I have my, let's say that let's say view account details. So this is my public key. This is my public key. Okay, and I can export my private key. The private key is where I can export it. Okay. So give your password. Mine is password 1. Once I do it, I do confirm. I get my private key. You can export your private key. You can store your public key also. Hello. Any questions, Srini? Any one of you? If anyone is stuck, please tell me.
I think somehow, yeah, I'm in this screen right now, let's say, the one you're showing, but I
Okay.
haven't necessarily, do I need to store this private and public keys? I probably,
No need. No need. No need.
no, then, okay, so as long as
Only
I'm
this.
able to log in and see this screen, that's good enough, right?
That's good enough. But then say, let's say that you have changed your browser, or if you want to do it from a different system, you
Uh-huh.
need just those 12 words. You can carry those 12 words, or you can remember those 12 words.
Oh, okay, so this is not like one-time thing. This is more like I got to carry the secret phrase all the time. Okay.
Yeah, yeah. If you have, if you're doing business on this, but right now just we are testing and all these things, you do not have to be that vigilant about it. But then in future, when you work with Ethereum or
Okay.
something, yeah,
Okay, that's good to know. Thanks.
yeah.
Ash, I'm trying to follow your notes. I tried to use the term MetaMask thing, right? It took me to deposit either, like directly deposit either, buy on Coinbase, deposit with Shapeshift. Which one?
Uh, you should have selected the first one only, no? The first one, if you would have selected.
Directly
See,
deposit either.
no, no. What all are there? Okay, you're saying one minute expanded view. I think you're one minute expanded view.
Directly deposit either. And the second
Uh,
option is giving you buy on Coin.
Where is that?
Third one is deposit with Shapeshift
No, no. Do deposit ether. Just do deposit ether.
either. Oh, okay. Okay.
Yeah. So everyone has completed it.
So then that took me to account one, view account on either scan or export private key. Maybe I missed the
Uh,
first step. Okay. So which one, view account on either scan or export private key? That should be my next step.
why is that coming actually? It should come like this. No, first has it shown this at least to you? Has it shown this to you? This one.
Okay, never mind. Maybe I missed the first step. I will redo it later. Yeah, I think maybe I didn't follow. I didn't follow the complete steps.
Yeah, fine. Can you guys just check the recording, or else after the class I can tell you. Okay.
Yeah, that's okay. I will follow the recording. Yeah, that's
Yeah.
fine. Yeah, don't mind.
So all of you, rest of you, you have this thing. You either you can see it like this, like as a drop
Yes.
down. You can draw it, so you see it as a drop down. You see it as a drop down, or like you can see it like this. Yeah. So any one of you, so it's done, right? So now what we'll do is we'll try to deposit certain ethers into our account. Okay. So how will we deposit certain ether? I think most of you people have done it, but then most of the people haven't done. So let's do it. So we'll go to faucet, faucet.metamask.io. I'll send the link in the chat. Just copy this. Go to this link. Everyone is on this page.
Yes.
Yeah. So now what is happening is, see this address, this is your address. If you open your MetaMask here, you see it as a drop down. You can see that your address is this one, 0x9346, this one. This particular website automatically asks your Chrome extension about your public address, and the Chrome extension returns this, and it's getting mapped. If you can see the account one, the same account is here. Okay. Now what we need to do is that I need to request for one ether from Faucet. So Faucet is nothing but it is a repository of dummy ethers. Okay. Now basically you cannot get main ethers, but then I can get testnet ethers. Okay. So I am in Ropsten, so it's a test network. You can select it like this. See, you go here, you select. This is the main network. You have three different test networks. See, but then select the Ropsten test network. Once you select the Ropsten test network, what you can do is it gives you dummy ethers. We are not transferring real ethers here. We are transferring dummy ethers or test ethers on the test network. So the main network will be having the main Ethereum or Ethereum and the ethers, main ethers, and the test Ethereum test networks will be having the test ethers. So here we are actually transferring that one test ether from this faucet, which this website handles. Website has, let's say this is the website site. This is the address of this particular wallet, which this website has. The private keys of this particular address is with this particular website, faucet.metamask.io, and I'm requesting for one ether. Now, when I request for one ether, what happens is that it sends that one ether to my account. Okay, request for one ether and do connect. Press connect. It will send one ether to you. Hello.
Yeah, we just clicked that. We wanted to check whether it updated one ether or not.
Yeah, request one ether. Now, actually, the transaction at RPC payload error. Some error is coming. Just a minute. Let's request. Split a transaction hash here technically.
Is at the same problem.
So did you also are getting an error here?
Correct. Similar
Then
error.
so I think there is a problem with this. We'll do one thing. We'll go to some other website. Option. Ether faucet. This one. So I think that web app is down actually. There is a certain issue with that web app. So go to this and try this. Let's try to get it from here. Okay. Okay. Everyone is getting the same errors. Chalo. Then leave that. Leave that thing and go to this link. And here send me test ether. Let me check whether here I'll be successful or not. Yeah, I got a transaction. Yeah. So you can go to this link.
So you're trying a different link?
Yeah, I send the yeah. I send the new link.
Right. Ropsten. Awesome.
There is some issue going on with this testnet, I guess. As I see, we got a transaction hash though, but then other concept.
Okay, why don't you complete one and then we can follow through later.
No, the thing is that that one is only not going through. That basically there is an error. There is an error with the network.
Okay. Even the other one too, Ropsten too. Okay.
We'll try Rinkeby then. Try Rinkeby. Let's do this. There are certain issues, guys. I think it's not going through. Okay. So technically, what should happen is that when I request, right? When I request, I press request, I should get 1 Ether here. Okay, that's what actually happens. But then there are certain issues with this. I think I got some Ethers. Yeah, yeah. See. I got one. I got 0.01 Ethers here. Just check this link. Yeah. Teja has got some testnet sent to. No. Okay, Teja. Unlike Teja. So I think you can go here, guys. The next link which I have sent, you can go here and in your MetaMask, go there, go to your MetaMask, select Rinkaby, okay, and then copy the address, copy it, paste it here, and do submit. Okay, test it, send to this. Okay, so where did you get this, Teja? This is where? This is in the new link. Is this in the second link? Is it, or the third link which I sent? Okay, you got it here.
So ring B worked for me too. I also got 1001 Ethereum
Where did you get that?
from ring B.
From
Either,
Rinkaby, right? Yeah,
yeah.
Rinkaby, you got it. Even Robston is working. I think the second link which I sent, that is sending out ethers. Teja got it. Even I got it. See, I got the same thing. If I just copy this one and paste it. Yeah, you can go here, and then I think you all would have got if you had tried this.
Which one is it? Robston?
Robston, the second link which I had sent.
Oh, that's working. You think is that
Yeah,
working?
it's working because I got 1 Ether just now.
Or maybe it's taking a little time.
Yeah, it's taking a bit of time. There is some issues. Generally, it doesn't have issues. Now it has. Anyhow, you can do one thing here. So, guys, so where are you right now? Guys, can you tell me where are you? Surya, Srini, Revan, all of you, where are you right now? Teja, I think you are done. You got the ether. Okay, you are done. The rest of all.
It says for me to, I mean, the other ones failed. I'm trying again with Robson, and it is asking me to do send, okay, enter your testnet account address.
Yeah. So what you need to do is, Srini, this is in Robston, right? This is in Robston, right?
Correct. Yeah.
Yeah. So when you select the Robston, see my screen. So press here.
Hold on. Sorry. Okay. Press where?
You press here. Account one. Press on this. It will copy. It will say copied. Copy to clipboard. Copied.
Oh, okay. Gotcha.
Then
And then,
paste it.
gotcha. Okay. Let me try that.
Yeah.
The address is not common across all the accounts, right? It's specific to, it's unique to each account.
Sorry, Surya. So Teja, right? Tell me, Teja.
The account
Okay.
The address is unique to each network. It's unique. It's not, you cannot use one address and across all the networks, right?
No address. No. It will be different. It will be same. Sorry, the address will be same for any network you go. The address will be same.
Oh, address will
Because
be, okay.
yeah, the address will be same. See, that is what is the thing. See, the thing is that the way the keys are being generated is following the same processes in any network. Okay, so this is for Ethereum only. Okay, this is a process for Ethereum. For Bitcoin, it will be different. For other blockchain, it might be different. But for Ethereum, this will be a process for any testnet or it might be mainnet. It will be same. The private key will be same. The public key will be same. So take care your public and private keys. Don't give your test public private keys also to anyone. Don't give your private test keys also to anyone.
Okay.
Got it? Yeah.
So
So tell me.
yeah, yeah, I think I got it. How do I refresh my balance? Just go and
Yeah, just close it and open it. Just close it and open it, or like change the
oh,
network, go back to the network, change
gotcha.
the.
I'm gonna do that.
So just change like this and go back. Then also it will refresh. So now what you can do is you can just copy your address, which you have already copied. Rest of no one is actually responding. I don't know whether you're doing it on Surya,
Yeah,
Venkat.
I got it. The 1 cent or one Ethereum, sorry, 0.01 Ethereum from Ringby, but it looks like Robston. They are saying that I'm in the gray list for 23 more hours. So
Ah, in Venkat, you got it. Huh?
yeah, in Ringby I got 0.01.
In Robson also check it. I think you'll get USC. Robson you would have got now. Just check it.
Yeah, I tried it. It says that I'm in the gray list for next 23 hours.
Pramod is also gray listed. Okay, I'll do one thing. Copy your
Yeah.
address and paste it here. I'll send it to you. Copy your address and paste it here.
Hey, this is Pramod. I actually
Yes.
got it for the first time when I did it, but when I redid it, and then I was grey listed.
No issues. Now
Right.
you have one Ethereum. Now you have one Ethereum in your wallet. Now in your address. Like
Ye-
when you click on this, and when you see Robston, are you able to see one Ether here?
Oh, you're going to see in Robson, not MetaMask. Oh, yeah, I did Robson. Hold on. I think mine. I think that's what is happening. For the first time, it is allowing, and then it's showing real estate. The reason I tried second time is because I couldn't see the value, although it said it was successful. Let me
That's fine.
read.
Sir. That's
Okay.
fine. What I'm saying is that when you open Robston here on the MetaMask, are you able to see one Ether? Srini and Pramod, all of you, are you able to see that one Ether? If it is not seeing, also
Uh,
fine.
no, I don't see it. It says
Uh,
0.
no, hold on. I think we need to select the right one there.
Yeah.
By default, it's giving main Ethereum network, so I got to select Robson. Yeah, you're right. I got it.
Yeah, you have to select Robston here. Yes. Are you selecting it like this? Are you seeing my screen? Are you selecting here the network? Select the Robston. Yeah.
Yeah.
Now I got the address of whom? Someone has sent me an address. Okay, Surya. Surya has sent me the address. 1 minute. Let me send him some ethers. Okay. So this is his address. Okay. Now I am on the Robston network. Surya has sent me his address. Okay. I'm trying to send him. So what I'll do is I'll just close it. I'll just open it again. So see, now just look into my screen. Okay, everyone just look into my screen. Now I open this MetaMask, right? I open this MetaMask and I'm trying to send it to Surya. So here once I do send, it is saying from my account, who is the recipient address? I'll be pasting that. I pasted his address. Okay, he sent me in chat. I have pasted his address. Okay, how much I want to send? I want to send 0.5 ethers to him because I have one ether, right? So I want to send him zero point 0.5 ethers. Now, when I go, I press next. Once I press next, it's saying some transaction fee and gas about which we'll learn in tomorrow's class. Okay, I do confirm. Okay, once I do confirm, it's saying pending. Okay, let's see when it gets done. If it gets done, he'll get the 0.5 ethers. See, I got confirmed transaction. I think you might have got it, Surya. Check it.
Yeah, I got it.
Yeah, so that's what. So now, yeah, so this is one. So just keep looking at my screen. I think you can play around with it later. Okay. Now that this transaction has happened, that is fine. Now there should be some logs, right, where we can go and see. So for every test, every network, it has its own, a web app called as, Etherscan. For Robson, it is Robson.Etherscan. For main network, it is only Etherscan. Okay, for Robson, it has its own Etherscan. If you want to know my transaction is added to which block and how it is happening, all those things you can see it in this web app. Now, the transaction which I did, right? The transaction which I did, actually, I can click on the transaction, okay? And here on details, there is a view on Etherscan button, okay? I press on this. Once I press on this, I get redirected here. Okay. Now let's understand what is there in a transaction and what are being added in the block. This I'm speaking. This is about the Robson blockchain, Robson test network. In the Robson test network, see, it has a transaction hash. The whole transaction has an hash. Okay. And the receipt status is success. That is, my money has been sent to, my ethers have been sent to Surya. And on which block it has been added? It has been added on 48 lakh 14,000 was, that is 4.8 million. Okay, that is 4.8 million block height. That is this block number. My transaction has been added when it was done a minute ago on January 12th. Okay, from whom to whom? This is my address from me to him. The value was this much. Gas and gas limit I will be explaining you later. The total gas price or the transaction fee, the total transaction fee is 0.0042 ethers. I have paid this much transaction to basically send my ethers to Surya. So this is how you verify. This is a web application. Anyone can access it. And from the MetaMask, whenever you do a transaction, just click on the transaction and view details. You can check it there also. You can view details and you can check your transaction here. I would suggest you people to do one transaction to, anyone. Let's say I think Revant has sent his address. If anyone has got one ether, send it to Revant. Send 0.5 ether to Revant. I'll put his address. Yeah, you can copy his address and then you can send some ethers to him and then verify it on Etherscan. I think Surya, you can send it to someone. If anyone can send, to put it to everyone, send your addresses on everyone. Srini, you can get it from Surya, I guess.
Yeah,
Or
I'm doing for Revant right now.
Yeah, and then anyone else, you can copy paste it to everyone, so that just copy paste it to so that anyone can pick someone else and send 0.5 ethers. Don't send the whole 1 ether. This is Teja. Okay. Guys, paste it on everyone. Don't send it to me privately. So this is Teja.
So by default, select fast one, transaction fee.
Last one, whatever it is. Like it depends. It is a middle one, I guess. No, by default it takes the middle.
By the middle one. Yeah, okay.
Yeah, take the middle one. I'll speak about it in the next class. Okay. Just send it first.
Yeah, done. And it's
Yes.
pending. I just quarter ether.
Okay, great. So Srini is sending to whom?
I think
Revant, correct?
Revant. Yeah.
Now Surya send it to Teja, and anyone else, Venkat or Pramod, Raj, any one of you, send it to each other.
So if I want to get some money from somebody, I share the public key. Is that what it is?
Correct, 100%. Yeah.
Okay, let me try to. Get my private public key rather.
So any other transactions happening or like nothing? Srini, you are done, right? Srini is done.
Yep.
Revant, I don't know how did he get the amount or not. Surya Teja going on. Yeah. So guys, so do one transaction and then check it on Etherscan so that you can understand, what happens on Etherscan and what MetaMask is doing. MetaMask is actually placing a transaction on the network, and the transaction is basically tracked on the Etherscan. Etherscan is a web app, you know.
Yeah, I got.
Great, Revant, great. Now, Srini.
Yeah, I sent my key. My transaction is confirmed.
Oh, okay. The transaction, great, great. So, did you go to the Etherscan and check it? Did you get something like that on my screen?
Okay, let me do that. I'll, I could see the activity log by double clicking. And how do I go there to that transaction information?
Yeah, how you need to go is that you press here, click on the activity, click on
Oh,
this, click
hold
on
on,
this,
sorry.
and
Oh,
here, view on Etherscan.
oh, okay. View on Etherscan. Okay.
Yeah.
Oh, yeah. Gotcha.
Yeah. So, guys, I think most of you might be seeing this. So, I just want to explain one small thing. Here in block height, okay, just check yours also later. Now, look at my screen, all of you. In the
Hmm.
block height, you can see that there is 4 block confirmations.
Right.
Okay, there's something called as 4 block. So, what does this mean? Any guesses? Any guesses? It is something related to what I have taught today. Any guess? Small guess. Four
Is that
block.
the hash sign? Hash, whatever that is. Previous
Mm,
hash?
no, it's not like that. It's why
Okay.
is it saying 4 block confirmations? Block height and then bracket 4 block confirmations. Why is it saying?
Yeah,
Is
for
it
each
for nodes?
transactions, we need at least for Ethereum, maybe 40 confirmations or something are required, right? I
No,
don't know exactly.
that's different. That's different. See, I was speaking about stale uncle blocks and all, right? So what this
Mhm.
means is that your block, your transaction was added to this block, and on top of this block, 4 blocks have already been mined. You understand?
Oh,
What? Yeah. So that means that if 4 blocks are mined on top of your transaction, that means that you are on the main chain. You are not ending up on the uncle block or like stale block or something like that. It means that 4 block confirmations means number of blocks mined on top of the block in which your transaction was added.
so then isn't that the previous reference to the previous block that has been?
No. It has
Okay.
nothing to do. It has
Okay.
nothing. This is only a transaction, and this transaction was added. This is only about single transaction, and this transaction was added to this block. And
Hmm.
this block, on top of this block, 4 blocks have already been mined. Okay, so that is a reason it is saying 4 block confirmations.
Okay. So I got 10 block confirmation.
That's what I have 3 showing. Yeah, Teja has 3. So more the number of blocks confirmed, it means that more the chances are you are on the main chain. You know.
Oh,
That
okay.
is very important. Even if you do it in Coinbase or let's say, I think in Bittrex, if you do a transaction on Bittrex, it will say that we need 6 block confirmations. So that's the reason why, after 1 hour only you get the amount when you withdraw it from Bittrex or something. Bittrex is a US company. It's a cryptocurrency exchange. So there are different exchanges. So Coinbase also, if you do, I think it waits for 3 block confirmations if you withdraw your Bitcoins from the exchange to your personal wallet or like send it to some other exchange and all those things. So block confirmation is nothing but it is the validation that your transaction has been processed. It has not ended up in a stale block. Got
Okay.
it?
Mm-hmm.
So Harsha, is that nodes are doing the validation?
Yes, correct. Nodes are doing the validation. Correct. Yeah, Raj, correct. Yeah, so guys, any issues now? Any questions you can ask me? We're coming to
So,
the end.
so I was looking at the nonce in the details, nonce and position. You got like 0 and 0. I got 0 and 2.
Yeah, so your transaction was in the second position. You
Okay.
understand? In the block, your transaction was in the second position. My transaction was in the 0th position.
So that means you're the first one to initiate the transaction.
Correct, correct, correct. In that block, no. In that block, my transaction was the first to be listed.
Oh, okay.
Hmm.
And then somebody else's and then mine, yeah?
Correct, correct.
Okay.
Okay, guys, and thank you very much for today. We'll meet tomorrow. Okay. So it's
Thank
better you bug all the wins. I have also 0 and 2. Yeah, yeah. So fine, Teja, that is fine. So we'll might meet tomorrow. Please revise it. Okay, and thank you.
And sorry, Harsha, will you be sending the recordings to everybody for us to go through it one more time?
Yeah.